So this next question, going nowhere, Bella takes 108 seconds to swim 400 meters backstroke in a 50-meter Olympic pool. What's Bella's distance? Well, distance hopefully should be fairly straightforward. It's right there in the question. It's 400 meters. Now, as you know, sometimes distance is the same as displacement. So if we do a 100-meter sprint on a track, for example, distance, displacement, both 100 meters. But in a 50-meter swimming pool, we're swimming back and forth, back and forth. So 400 meters actually gets you back to the same spot as you started, and therefore the displacement of Bella during this race would be zero. It's a zero displacement between the start and the finish of that activity. So if speed is based on distance and velocity is based on displacement, then the calculation for speed should be fairly straightforward. It's the distance divided by time, or more accurately, change in distance divided by change in time. Now in this case, the change in distance and change in time is fairly easy because we have the 400 and we have the 108, so we're just taking those by zero really in terms of the change, and we get an average speed of 3.7 meters per second. Whereas the average velocity, which remember carries a resultant direction with it as well, and the resultant direction going back and forth, all those times ends up being zero. And so does the actual magnitude of zero. So zero displacement means zero velocity, and it would mean zero acceleration through that period of time as well if we're talking about those resultants.